Mr. Tarot, in this lesson we are going to go through 5 examples from easy in the beginning to a pretty difficult problem at the end of this lesson where we write inequalities from word problems. And that is the title of the video, how to set up equations, or not actually equations, but inequalities from word problems. But what's the point of writing them if you're not going to solve them? So we're actually going to solve them as well and graph them on a number line. So as far as setting up or graphing an inequality on a number line, well, and we're not going to be dealing with not equal to as our inequality, but these 4. X is greater than A, X is greater than or equal to A, X is less than A, and X is less than or equal to A. And the equal sign is pretty obvious in these symbols. And when you're looking at inequality symbols, the open side, sort of if you want to think of it as a mouth and it's wanting to eat, it's going to go towards the bigger number, whatever works to help you remember it. So this is going to be X. This is the open side of the inequality. So that's the greater than part A. And okay, so what do we got going on here? When you graph these on a number line, you're going to go identify where A is on the number line. And so and this is just in general terms, it's not a real number that we can concretely put down, but just in this general form of A, when it's not, or just in this example, X is greater than A, that is not part of the solution set. And when you graph or shade a number line off of an inequality statement, what you're trying to shade is the answers, the part of that number line that when you plug those numbers into the inequality, you get a true statement. So that means that if X has to be greater than A, that actual value of A is not part of the answer. So when you don't have an equal sign in your inequality, those dots are going to be open, indicating that while that value of A is some special marker on the number line, it's in the inequality, it's not part of the solution. Now, just as an example about graphing these on a number line, let me go ahead and take this A out and give us a concrete example. Well, and I also realized I didn't set my timer to make sure I don't run over my time. Let me do that really quick. Let's probably talk for a couple minutes so far. All right. Now I'm going to go ahead and say X is greater than 5. Now on the number line, we're going to have a value of 0, and then 1, 2, 3, 4, 5. Go a little bit farther and backwards, -1, -2. Every one of those tick marks, perfectly evenly spaced out, need to be representing a movement of 1, at least the way I've drawn this number line. I'm going to go ahead and put an open dot on that 5 and shade to the right, of course, just like I had with the A. Now, I just want to point out, again, with that open dot, if I said, okay, well, if this shaded area is supposed to be indicating the solutions in the number line that allow this inequality to be true, well, I started at 5. Well, what if I write 5 is greater than 5? Well, 5 is not greater than 5. 5 is equal, to 5, where that dot would be closed. But that is a false statement, thus that dot is open. But if I put a number that's just to the right of 5, maybe 5.5 or 6 or something like that, any number that is to the right, and of course our numbers are going to get larger or more positive to the right, and as you can see here, negative or smaller as we move to the left, 5.5 is indeed larger than 5. So if you needed a little reminder of how to graph inequalities on a number line, there you go. Okay, getting our magic picture in picture out of the way, my high-tech version, let's get on to our 5 examples. All real numbers that are at most 15. Well, how am I going to write an inequality for that? All numbers that are at most 15. If you're not sure, well, we're going to put all real numbers. So there's a statement about a number in this example, but we don't know what that value is, and that's going to be our inequality. I should probably use a different color chalk to differentiate my answers from the question. So let's get some orange going on here. We're comparing all real numbers to 15. Now, all real numbers, that's decimals, that's fractions, that's any kind of run-on decimal, like if you do well, this is rational, but if you do 1 divided by 3, it's 0.3 repeating to the right. It includes irrational numbers like pi, if you've heard about that number yet, I hope so. All real numbers on the number line, and all of those real numbers are at most 15. is it going to be, basically less than or greater than? And that might be kind of difficult to come up with unless we put some like real world setting to it. Like maybe I have a van that holds at most 15 people. In other words, there's 15 seats and 15 seat belts to go along it, for the safety. At most 15. Well, then I couldn't put 17 or 18 people in the van, and we can see that that's an enclosed space. There's a set number of seating, and it holds at most 15. Well, I can go up to and including 15, but I can't go over. I have to have numbers that are less than or equal to. That's how you set up an inequality for all real numbers that are at most 15. Now, shading of that, we can put a solid dot on the 15. Solid because at most would include the value of 15. And then we're going to shade to the left. So a little bit of review about, again, shading number lines based on an inequality. Now, I said I'm going to do 5 examples, but I want to change the wording of this a little bit, and I hope that the van idea gave you some insight as to why at most, something at most 15 means it has to be less than or equal to 15. What if I said, just change this. Now this is why I always need to watch my time on my lessons, because I sort of start thinking of different ideas as I'm doing a particular example. So let's see here. A van can hold at most 15 passengers. Well, now we can say, well, I don't know how many people are in the van. So and I just talked about at most, so that's going to be x is less than or equal to 15. And that number, why did I erase my number line? That shading started at 15 with that solid dot and went to the left forever. And let's just look at here. If I start at 15 and I shade for left forever, then I start including some negative numbers. Can you have a negative number of people on a bus? And of course the answer to that is no. So while that was a good answer for the pure mathematical equation, sentence, in this real world setting, that inequality wouldn't make any sense. So the van can have as many as 15 people, at most 15 people, and the least number of people on the van can be 0, empty. So that shaded on a number line, well, this gets into a little bit of a sticky situation as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, I got it all in there. How would I shade that? Now, we could think, okay, well, a solid dot at 0 because of an equal sign, a solid dot at 15, because we can hold, if we can hold at most 15 people, there's 15 seats, so 15 people can get in there, and we shade a continuous line between 0 and 15. And, maybe in certain circumstances or your teacher, that would be sufficient. And honestly, in some of my classes, I think I could probably take that as an answer as well. But it's a little bit, again, unrealistic applying this simple little sentence and, this idea of inequalities and shading on a number line. If I shade that solid, I'm including every single real number because this is a number line between 0 and 15. And am I going to get 1.23 people on a van? That doesn't make any sense. So a solid line with my new revised example would be, really technically incorrect. And my shading for the number line kind of really isn't any shading for inequalities anymore. Well, other than I have an inequality there, so maybe I misspoke a little bit. I'd have to put a little, okay, I'm not going to have time to do that. I'd have to put a little individual dot over every single whole number value between 0 and 15 because that would be appropriate for the setting of people going onto a van and filling the seats up and how many people can be on the van. So, this math gets the foundation of math that you're learning in this sort of pure algebraic class has real life applications, but it gets a bit more complicated when you think about the appropriateness of your numbers and how they apply to that real world setting. 7 is less than 4, which is less than a number. Again, a general expression about just some random a number. Well, not maybe totally random, but an unknown number. So that is going to represent a variable of x or a or b or c or whatever letter you feel like being that that variable, and 7 is less than 4. Well, when you're writing an equation, I have other lessons, and I'll put links to those lessons in the description of this video if you'd like to go watch them about setting up equations from word problems. And we know the word is an equal sign, which breaks your left side and your right side of your equation up, or just, defines the left and right hand side of your equation. And that kind of does the same thing here with inequalities. Is less than, that indicates, that definition between the left and right hand side of the equation, but it's not going to be an equal sign, it's less than. So 7 is less than 4. And now I'm looking at the same two words together, like what's going on? Is less than is a less than symbol, but now I see less than and more than. If there's not that word is next to it, then you go into addition and subtraction, or sum and difference. For less than a number, well, less than, when you're not putting an inequality symbol, there's no word is going to be subtraction, and if it said more than, it would be an addition. And for less than a number, well, what you have to do with the two words together, less than and more than, is you have to indicate or remember, well, is it addition or subtraction? And you also have to remember to turn around the equation. So this is going to be 7 is less than 4. Not really. I should have just stopped at the less than symbol. It's 4 less than another unknown number. So it's actually x minus 4. And remember to turn that around is kind of a big deal. Now, I have no idea. I'm just going to make up something kind of simple here. I have $10 in my wallet. Okay? Now, if I look at you in the camera on the other side, the student, thank you for watching, by the way, and I say you have 2 less or 2 fewer dollars, or you have, the money in your wallet is $2 less than what I have. Now, I had 10, and I just said, maybe as an example, you have $2 less than what I have. Well, if you don't change the order of the sentence around, it would be 2 minus 10. Well, 2 minus 10 is negative 8, and saying you have negative $8 in your wallet doesn't make any sense when you just have 2 fewer dollars than I have. Oh, you got to turn that around so you get sort of like an appropriate answer for that setting. 10 minus 2 is equal to 8. So more than, less than, addition, subtraction, but also you must remember to change the order of that, those values that are represented or spoken about in that equation, or that sentence, excuse me. And again, we're writing inequalities. So let's go ahead and solve this inequality. We want to get this negative 4 away from the 7, so we're going to drop the chalk down, and let's add 4 to both sides of this inequality to undo the subtraction of 4 that is with the x, and we get 7 plus 4 is 11, which is less than x. So, and I didn't point that out on the green board, 11 is less than x, which means if you read it in the opposite direction, x is greater than 11. Or I could actually write it in the opposite order, which I always cringe a little bit when my students do it because they often forget to change the direction of the inequality sign with it. And placing that on the number line, we're going to have, put an open dot. There's no equal sign on the 11. And I guess we'll do this in yellow. Open dot. And x is greater than 11, or 11 must be less than all of the numbers that are represented by the shaded region in our number line, or x. So we're going to shade to the right, because if I shade to the right, I'm shading the area that is again, where those x values are that are going to make this statement true. And if I say, I'm shading towards a value of 12, and I put 12 in for x, yes, 11 is less than 12. And then if I want to check any of these answers to make sure that I'm indeed shading the correct side of the number line, I can say, well, I shaded to the right of 11. Just as an example, 12 is in that area, and we get 7 is less than, I'm going to plug in a number within that shaded region, 12, minus 4, and we get 7 is less than, well, 12 minus 4 is 8. 7 is smaller than 8, so that is true. We've checked out. We have shaded the correct side of our number line. To get free shipping, you must spend at least $50. If we shop online, whether it's just online retailers or even some like, brick and mortar stores that are selling online as well, they often will give, they'll send that package to your house for free if you spend enough money. And I guess if you spend enough money, they make enough profit to cover the shipping costs, and so they tell you that it's free. So to get free shipping, you must spend at least $50. So what you're spending, and again, this sort of real life scenario here, I think it makes sense to know, we kind of probably more naturally know that, yeah, we need to spend at least 50, we need to spend $50 or more. They need to sell that product at a high enough price to make enough profit to cover the cost, basically, of the shipping. So the spending is at least $50 or 50 greater than or equal to 50, equal sign, solid dot, and greater than, well, the numbers get bigger as you go to the right. Excellent. Moving on, you have a 200 gigabyte hard drive with 76 gigabytes already used. You need to store videos on that average a size of 5.5 gigabytes, or we usually just say gigs, in size within the remaining space of your hard drive. Write an inequality that represents this and solve it. Okay, let's kind of shift back into sort of like, how do you write equations? What's the independent and dependent variable? We have a discussion here about the amount of space on a hard drive. Some space is already taken up, and now we're going to come in and we're going to take up more of that space that is going to be accounted for by the number of videos that we're putting on there. So what is the independent and dependent variable? What is the independent variable? What's the input variable? In many situations, you have control over what that independent variable would be. And well, I'm taking up memory right now making this recording, and I had control over whether I made this lesson for you or not. So the number of videos is the independent variable. Now, the space used, if you will, is going to be dependent on the number of videos. I'm using words, but I'm really using function notation as well. I'm going to call this, I don't know, I'm going to just call it function S for space, and my independent variable is V for videos. My space used is equal to, well, it's equal to now the 200 is the overall storage, and I'm going to use that in a minute, but right now what's been used? The 76 gigs that are already on the hard drive for whatever that may be. And then to that, we're going to add 5.5 gigs of space used for every video I put on. So that, every video, more and more, 5.5 on average for each one of those. So the 5.5 is the value that is going to be repeated. And I do have, again, links to other lessons in my, in this lesson, that you can go and see more examples where I'm setting up word problems, or setting up equations, from word problems. I'm speaking a lot in this one for some reason. Now, the space used, this expression, describing how much space you're using in the hard drive, well, the total amount of space available is 200. So this space used, 76 plus 5.5, and let's just call it V for videos, must be, well, you can't go over the physical storage, so it has to be less than, I guess, and technically I could maybe fill it up exactly, probably not really in the world of computers, but that space used, we set up an equation. Well, that expression describing that has to be less than or equal to 200. And now solving this one, now we're going to, from a one-step inequality to a two-step inequality. I got a 76 and a 55 on the left side of this inequality with the variable v. We need to get them alone. On the left side here, we have an addition, a positive constant, an addition of 76. We're going to undo that, apply an inverse math operation, which is going to subtract 76 from both sides. We get 5.5v is less than or equal to 200 minus 70 is 130, and 130 minus 6 is 124. Well, I use a digital SLR to record my lessons, and I cannot record more than 20 minutes. And my timer did not, well, it actually did go off, but the volume was not on my iPad, so I had no idea I was running out of time. But thankfully, I was very, very close We went ahead and subtracted 76. We divided by 5.5, and we got V is less than or equal to 22.5. Now, in the context of this real-world problem, well, unless I want to store part of my lesson on one hard drive and part of my lesson on another hard drive, and for some reason maybe just lose track of it and lose part of my lesson, I wouldn't want to do that. If I want to have, full lessons at this average size and have them all together, like, complete on a hard drive, that needs to be rounded down. Now, I say maybe rounding is not the right word, because if you round 22.5, you're going to round up to 23. And that would push us over the maximum storage of 200. So you're kind of, I guess, truncating. I'm truncating this decimal of 0.55, just cutting it right off, and saying that I can store 22 videos or less on this hard drive with a maximum storage of 200. Now, again, we're sort of needing to realize that we cannot let that inequality or that statement of or less extend down into the negative values in the number line, because that would not make any sense that you could have a negative number of videos on a hard drive. One more example. It's going to be pretty difficult algebraically, but that's how lessons go, right? You start easy in the beginning, you work your way to the end, and get some pretty challenging problems, especially just for an Algebra 1 student, at the end of your lesson, but I hope we can understand it when I'm done. No. So, for our last example, we've got that you are earning money by tutoring for $20 per hour and working at the store earning $8.50 an hour, $8.50 an hour. Now, why would you want to do both? Maybe, the tutoring jobs are just occasional, not a regular income that you can count on, just something that comes up every once in a while, and then you have that regular job, that 9-to-5 job, if you will, where you maybe even have some benefits earning you $8.50 an hour. So what is the greatest number of hours you can work at the store? So we're definitely having to maintain some hours at the store. If you can only work a total of 15 hours, and you need to, in a period of time, within that 15 hours of working time, need to earn at least $173.50. Now, at least. We could work all, maybe we could work all 15 hours at $20 an hour and have even more money than that. But if we need to have at least an earned income of at least $173.50, how many hours could you work in the store with a combination of tutoring? Because you don't want to lose that job maybe, right? Because it has some regular pay and benefits or whatever. Now, we're still having a couple of things that we're comparing, total earnings, and of course the number of hours. And the number of hours, that is determining how much you pay. So the number of hours is going to be our independent variable, and the earnings will be our dependent. What's making up our earnings? Because setting up equations and inequalities are not easy. Well, we have some money coming in from tutoring, right? I'm not even trying to think of a formula, right? It's just what's going on. I have money coming in from tutoring. I have money coming in from basically my store job, my regular job. And then what? Well, together they're making up my total income, my total pay. Okay. Now, how do you, when you work by the hour, when you have an hourly job, you know that, well, maybe if you do work, and if not, you at some point you will be working, I'm sure, for an hourly wage. If you make $8 or $10 an hour, first hour $10, second hour another $10, now you're at $20. Third hour another $10, and now you're repeatedly adding an additional $10 for every hour. Well, we're going to be repeatedly adding either $8.50 or $20 for every hour worked, and repeated addition is multiplication. So the tutoring, well, that's $20 an hour times, some variable that represents the number of hours. Okay, so I don't know, X, because I don't know how many hours I tutored. And then going to the store, I think maybe the dollar sign is going to be distracting in there. We're going to be at the store, maybe our more normal, regular job that we can count on getting some money every week from is $8.50. And I don't know how many hours I worked at the store, so maybe that's just another variable Y. And then total, well, that's $173.50, but really that's not correct. Well, the whole thing is not really finished at all, period. But it's not correct to say that I want my pay to equal $173.50 because, you know, what's wrong with making more, right? We want to make at least $173.50, maybe to pay for a monthly bill or something. So this equal sign is not really appropriate. We want to make some money, and if I make more, that's okay, but I need to make at least. So if I can make $173.50, maybe I can buy whatever I want, or there's some regular bill at the end of the month. I don't know, insurance bill maybe, car insurance. But whatever it is, if I make more, that is okay. Now this is not really a complete picture either, because I have an inequality set up with two variables in it. And if you're just the beginning of Algebra 1, you probably haven't even seen anything like that. And it wouldn't be solvable anyway. Very rarely can you solve for two variables in the same equation. There's some situations where you can, but if we're just in the beginning of let's try this again, beginning stages of algebra, that would be impossible based on your skill set. And you know, even if we're advanced, that's not solvable. So we need to go into this problem and find some more information. What have I not used yet? I've used the total income of $173, the hourly pay for tutoring, the hourly pay for the store. I haven't used the 15 hours total that we're limited to in this problem for working. So really the number of hours that I spend tutoring and the number of hours I'm spending at the store, they're not really completely unrelated. It's not just an X and a Y. Say, I'm going to have to erase this in a second, but let's say that I spend 2 hours tutoring. Well, how many hours is that going to leave me at the store? Total of 15. That's going to be 13, right? And my students often would just throw that number out and they got to go, well, how did you find 13? Well, that's 15 hours that was total minus the 2 that you spent tutoring leaves you a remainder of 13 hours for the store. If you spend 5 hours tutoring and you can only work a total of 15, that leaves you with 10 hours left for the other store. If you work 7 hours, I'm going to stop after this. If you do 7 hours of tutoring and you can only work a total of 15, that leaves you with 8 hours left to work at the store. Now, I'm making up concrete numbers because we've been doing arithmetic since we were just little tiny kids, and the abstract idea of algebra maybe wasn't introduced until much later, and even if it wasn't, still abstract ideas of algebra sometimes are more difficult to see the pattern. But 2, 5, and 7, well, I'm just taking each of those numbers and subtracting them from 15 to find out how many hours I could work at the store. I could flip-flop this, doesn't make any difference. I could do all this for the store and this for tutoring, whatever. The point is the relationship between the hours at one job and the hours at the other are related by that total of 15, and we're subtracting these from 15 to find that remaining hours of time left. And we do want the hours that we can work at the store, so let's just let X, or I guess I've already used X, right? So that's kind of a problem. Well, no, it's not. Let's use H for hours. 850 times H, the number of hours for the store. Well, for tutoring, remembering that pattern I probably shouldn't have erased yet, the number of hours that leaves me, whatever number of hours I work at the store, that's going to leave me 15 minus H for the number of hours I have left to tutor and try and earn this minimum income of $173.50. Or, remember, I can make that much or more would be okay. And that is a pretty difficult setup for, maybe not for you, I don't know, but it is a fairly difficult setup for especially early stages of algebra students trying to figure that out. Well, now we got it. We have an inequality. We've only got one variable. Now this is a multi-stage inequality, so maybe really moving ahead for some of you. 20 times 15, well, 2 times 15, well, 2 times 10 is 20, and 2 times 5 is 10, 20 and 10 is 30. Add on a 0, we're looking at 300 minus 20h plus 850h is greater than or equal to 173.5. We're going to go ahead and do negative 20, combine the negative 20h. These are like terms. Let's just highlight that with a different color. Negative 20, and I hope the yellow is enough of a different color. Like terms, so we're doing negative 20 plus 850. Okay, well, if I'm combining numbers with different signs, I want to subtract those numbers and keep the sign of the largest absolute value number, or kind of just ignore the negatives there, and 20 is the sort of quote-unquote quote bigger number. So 20 minus 850. Well, 20 minus 8 is 12, and 12 minus, if thinking of dollars maybe, if you have $12 and you spend another 50 cents, that leaves you with 1150. But our bigger absolute value is negative, so it's going to be 300. Now that I'm talking, I hope I don't forget what I just said. Minus 1150, don't forget the decimal like I just did. H is greater than or equal to 173.50. Now we're going to subtract both sides by 300. We're going to get negative 1150. H is greater than or equal to 300. Well, it's going to be negative. 300 minus 100 is 200. Now 200 minus 70 is 130. 130 minus 3 is 127. And now we're at 126.50. If you do your mental math with addition and subtraction, if you go left and right, you don't have to do any borrow and carryover stuff. And I just do want to make sure I didn't make any mistakes. Now we're going to undo that multiplication of 1150. And we get H, and now we're getting to the last little bit. It really, again, this was supposed to be about just setting up inequalities, but then I thought, well, why set them up and never really solve them? This is the only issue with solving inequalities compared to solving equations. When you multiply or divide both sides of the equation by a negative number, you need to remember to switch the direction of the sign. So the number of hours at the store is not greater than, but must be less than or equal to, no, I can't do that in my head, 11 hours. Let's see here. Yeah, I hope I didn't round that off. And that H is less than or equal to 11 hours. That's the number of hours, 11 hours. So you can work 11 hours or less at the store. Now I kind of just stopped immediately and said, well, I'm done. Now I haven't checked it. If you want to check it, you can plug 11 back into here and make sure you get a value that is greater than or equal to 173.5. There's no round off error. It will be 173.5, and then you can plug in a number that's maybe 10 or 9 or 8 to see if you get a bigger income. When you do word problems, especially something quite as complicated as this, make sure you're actually answering the question. Just because you have a variable answer doesn't mean you're really done. Now, we had an expression for the number of store hours, and we had an expression for the number of tutoring hours. If I wanted to know how many hours you could tutor, I would need to do some kind of manipulation with the fact that tutoring is 15 minus h. So 15 minus h is, 15 minus 11 is 4. And we'd have to kind of turn that around a little bit and say that we could work, 4 hours or more tutoring. But I wanted to make sure, especially because you have a little bit of like more or less, what's correct, I wanted to make sure when I set up the problem that just my generic variable of h did represent the store hours, so that when I was done, I was assured that I was looking at the right value. And that is the end of my last example. Bit of a long lesson for what maybe seemed like a simple topic based on the title of the video, but I hope through the number lines and the solving inequalities and setting up some rather complicated word problems, I've helped you understand how to do your homework. I'm Mr. Drew. Bam! Go do that homework.